Hi, OpenXML developers. This is Eric White. Today I am going to walk through the process of accessing an OpenXML spreadsheet using the OpenXML SDK for JavaScript. I received a question on the forums recently about how to do this, and as I was putting together the example that showed how to do this, I thought that the process of me putting together this example might be interesting to lots of OpenXML for JavaScript developers. I use lots of little techniques and tricks and tools in order to do what I need to do, and I realized that a lot of this information currently is only in my own head, and I want to get it out of my head and show other people some of the little approaches that I use to get a job done using the OpenXML SDK for JavaScript. So our task today is to open up a workbook and a worksheet with a given name, and then once we have opened up that workbook and worksheet, we want to change the value of the upper left cell to some particular value. It's a very simple example. We don't really care in this case how complicated the code is to modify the workbook and worksheet. What we really care about is the plumbing necessary to get going here. Later on, I'll have lots to say about how to most effectively and efficiently operate on workbooks and worksheets. There's going to be lots of fun things that we're going to be doing with that, but that's not the subject of today's screencast. Today we're just focusing on the mechanics of opening up a workbook, opening up a worksheet with a given name, and changing a value. So to do this today, I'm going to make a new example, example number 10, and I'll be including this example also in the OpenXML SDK for JavaScript zip file. That's our job for today, so let's get started and let's make a new example. In this folder, I have unzipped the 1.1 delivery of the OpenXML SDK for JavaScript. This is the stock delivery unzipped. So let's open up the Visual Studio project. Here's the first thing is we get this security warning for opening up that project because I downloaded this project from the web. So I'm going to just cancel this and close this. One of the things I love about PowerShell is I can come right up here into the address bar for Windows Explorer and I can type in PowerShell. Actually, all you have to do is type PO-tab and then it will auto-complete to PowerShell, at least after you've done it one time. Then press enter. And it opens up a PowerShell console in the folder that I was in. So now I can do dir star.star dash recurse and then pipe that into unblock file and press enter. And we have unblocked every single file in that hierarchy of folders. One point about this is that you need PowerShell 3.0 in order for this to work. And if you're using Windows 8, 3.0 is included by default. But if you're using Windows 7 or before, you don't have 3.0. But I highly recommend just upgrade to 3.0. There are a few features in 3.0, such as this one, having that unblock file commandlet available, that just make it really indispensable for me. I don't even bother doing anything else other than upgrading to 3.0. So now we can go back and open up our solution. And this time we don't get any errors, of course, or we don't get any warnings that we're opening up a untrusted file that was downloaded from the internet. So we want to take example 9, which is open a base64 docx, and it opens it up in asynchronous. And I'm going to start with that example. It's generally good to use the asynchronous versions of all of the various file open and file save operations in the OpenXML SDK for JavaScript. It works fine without using asynchronous as long as you're using small files, but sooner or later you're going to want to open up a large file, and there's no good reason not to just use the asynchronous versions. So I'm going to take this example 09 open base64 async.html, and I'm going to just copy and paste it. Now we have this copy of example 09, and I'm going to press F2, and I am going to change this to example 10, and I'll call it open-modify-Xlsx. This is going to open and modify an Xlsx. We have that open here, and what we'll see as we drop down here is this string literal in base64 encoded ASCII. And if we go down here to the bottom, the first thing that we see down here is we use doc.open from base64 async, and we pass in that template document. So if you looked at example 9, it opens up some random docx, and then it makes a little change to that docx, and then it saves it to a blob, and it also shows saving to a base64 async right here. We don't need to save to base64 async. We are going to use the save to blob async functionality. But the thing is we need to replace this base64 literal that has a docx in it. I want to replace that with a base64 literal that has an Xlsx in it. So let's go to our folder here. I'm going to right click and create a new Microsoft Excel worksheet. I'll call it test. Let's put a little bit of data into this worksheet. I'm going to put in 1, 2, 3, 4, 5, 6. And what I'm going to do is I'm going to write a small program that is going to change this upper left cell. In other words, this 1 is going to change it to 1000. It doesn't really matter what we're trying to do. We're just doing something simple to this worksheet and then resaving it. So I'll save it and close it. Now the next thing that I need to do is I need to get that binary file in a JavaScript literal that is base64 encoded ASCII. And let me show you how I do that. I have a screencast that talks about this in depth. You can look at that screencast here at this link. I'm going to show you the quick version of that screencast right here. First of all, I'm going to start up PowerShell, and I'm going to show you my profile. I'm going to open up this profile in the PowerShell ISE, and down at the bottom of this profile, this is the profile that I use on all the machines that I use with PowerShell. Incidentally, I do something where I have this profile stored on a SkyDrive folder so that when I make changes to this profile, it automatically gets propagated to every one of my machines that I use PowerShell on. And further, I have created a hard link to the Windows PowerShell folder on each one of the machines. That hard link is to my appropriate folder on SkyDrive, and therefore, once I've got this all set up, my profile automatically propagates to every machine without me doing anything. I could make a change to this profile right here, save it, and I'd go to another machine in about 30 seconds. It would be all as I wanted it to be on that machine. So here in this profile, one of the things that I do is I have this C# code here that creates a class called B64, and it has a convert to B64 and convert from B64 method in that class. And then right here, it calls add type. It uses the add type commandlet to add that type that was defined in that string. In other words, this SZ8 string, and it adds that to the environment for this particular PowerShell. Then I have three small PowerShell functions. First, I have this function convert to B64, and all that this function does is it has a parameter $path, and it calls the B64 class convert to B64 static method. And ditto for convert from B64 calls the convert from B64 method in the B64 class. And then finally, I have this method convert file to JavaScript literal, and this convert file to JavaScript literal uses the convert to B64 method, and it basically fabricates JavaScript literal syntax out of that. In other words, it puts the beginning quote and the ending quote and the comma on there. So let's go take a look at how these fellows work. So there's my test.xlsx. Let's first of all look at the convert to B64 method. And what we see when I run that is it simply converts that binary file to base64. And it also chunks it up into strings of 76 characters in length. And that's a lot more convenient to work with. And then if we look at this convert file to JavaScript literal, what it does is first calls resolve path, and that's just something to make sure that we have a good path. And then it calls convert to B64 and assigns that to $A. It then splits $A based on the /r/n. In other words, it's going to convert this long string that has carriage returns and line feeds, and it's going to convert that to an array of strings. Once it's converted that to an array of strings, then what it does is it uses this select object method to get all of the various elements in that array except for the last one, first of all, and it puts quotes, double quotes around the string, and also puts a plus on the end of it. And then at the very last one, what it does is it puts just double quotes around it. We don't want a trailing plus. And then finally what it does is it takes the results of that and pipes it to the clip executable. And since Windows Vista, I believe, clip is there, that it takes whatever is piped to it and puts it onto the clipboard. So if I come back over here to my PowerShell that's in my OpenXmlSdk for JavaScript folder, and I do convert file, let's try again, convert file to JavaScript literal test.xlsx, and I press enter, it doesn't actually show anything because it put everything on the clipboard. If I start up Notepad++, which is also one of my very important tools, and paste it, then we can see exactly what we expected to see, that string that contained base64 encoded ASCII is now been put on the clipboard with these double quotes there and a plus, all except for on the last line. Now that I have that on the clipboard as I want it to be, it's simply a matter of coming into my JavaScript application, and I need to select exactly the text from there to there and paste it. Here I'll put that semicolon at the end of the line so everything's nice and neat. And now I'm done. I now have that Xlsx with the values 1, 2, 3, 4, 5, 6 embedded in my JavaScript application as a string literal, so we can use it in our further processing of this spreadsheet. Now, next thing I need to do is I need to set things up so that I can use the predefined names that are predefined in the OpenXml.JavaScript. If I look for OpenXml.s, this is the class that contains all of the element names that I'm interested in using in my example here, these are the pre-atomized names. In other words, the predefined X names for all of the element names that you'll find in a spreadsheet. I could refer to those just using OpenXml.s. so on, but that's not the pattern that we like. So what I can do is I can just change this. I'm going to declare a variable s, and I'll set that equal to OpenXml.s. And I also know that I'm going to need the R namespace, or the relationship namespace, and so I'm going to set that up to be OpenXml.r, and I don't need this OpenXml.wns. That's not required. I should make a change up here to my title. I'm going to say shows opening a workbook worksheet and making a mod to the upper left cell. And we'll leave this button save there. It's using the HTML5 version of things. Now let's make the actual changes to our example here. One thing is that this example also showed saving to base 64 async, and then it demonstrated that it actually worked by using an alert to show us the first 10 characters of the B64 string. We don't need to do that. We're not interested in that. We're more interested in the plumbing of getting going with a workbook and worksheet. I can get rid of this. This all has to do with opening up a regular word processing document, not a spreadsheet. So we don't need that. We need to also change this down here. We're not going to save it as a saved template document. We're going to save it as a saved spreadsheet. And the extension should be, of course, Xlsx. Now at this point, I can run this example. It will work, and all it's going to do is it's going to show me the save button, and then when I save it using that save button, I should be able to open the file that I just saved. So I'll press F5 and it runs, and now I'll press save, and it says, do you want to save saved spreadsheet.xlsx from localhost? And I certainly do, and I'll save it on the desktop as saved spreadsheet.xlsx, and it has completed. Let's open that folder, and there's our saved spreadsheet.xlsx. And if I double click on that, sure enough, it opens up with our values that we set up in there, 1, 2, 3, 4, 5, 6. And this spreadsheet, it came from that string that was in the JavaScript literal, and I opened it and then saved it as a blob to my desktop, and everything worked just fine. That the spreadsheet was serialized properly, everything is working as it should. So let's close this, and while we're at it, let's just delete this. We don't need it there. We'll be creating a new different one. And I can shut down the application there. So let's go make the changes to this example to alter that upper left cell in the worksheet. Taking it a step at a time, first let's get the workbook part. So we get the workbook part by calling this convenience method workbook part. If you're not sure what these convenience methods are, go take a look at some of the earlier screencasts on the OpenXmlSdk for JavaScript. I'll show you really quickly what that's all about. If I go to workbook part, here it is it calls get part by relationship type, and it passes in this relationship type of OpenXml.relationshiptypes.workbook. So this is the functionality that you have to use when you're given a package and you need to get the workbook. Then you get that part by its relationship type, and this literal here has the actual relationship type as defined in the OpenXML standard. One thing is we've got this named opened document, and that really implies that it's a word processing document. So we'll call it opened spreadsheet, and I'll copy that and paste that in there and paste it into there. There's also this document to save. So let's go to the beginning of this and let's change this from document to save. We'll call it spreadsheet to save, and I'll change this to save spreadsheet. And also this should be our templates spreadsheet, just to make it so that our names of our variables reflect what we're actually working with here. We're working with workbooks and worksheets, not with documents. So now I have to change this to template spreadsheet. And this doc, I'll change it to Xlsx, and Xlsx here. Change that to spreadsheet to save, and spreadsheet to save there. And I'll change this alert to spreadsheet is not open, and change that variable there to spreadsheet to save. Just to double check and make sure that all of the changes just made are all correct, I'll run it again and type save, and then do save as, and saved spreadsheet gets put there in the desktop. Yes, and everything still is hanging together properly. So now we've got the workbook part out. Let's make sure that we can get the XML out of that workbook part. So I'll do var workbook xdoc is equal to workbook part.get x document. And then one thing that I want to do is I want to make sure that this all works properly. So I'll type var z is equal to workbook xdoc.toString, and I'll pass in true to that toString to tell it I want to format the XML, in other words, to indent it. And now I'll set a breakpoint right here, and I should be able to look at that z variable and make sure that it contains the contents of the workbook part. So I'll run, and there we hit our breakpoint, and there's our z variable. Let's pull up the text visualizer, and there, sure enough, is our workbook part. Now, what I often do is I just copy it. I select everything and Control-C that, and close this, and then come over here to my Notepad++ and paste it in there so I can look at it in a more easy way. So what we're going to do is we're going to look for the worksheet that has the name of Sheet 1 and get the resource ID out of that, because that's how you work with things. If you want to access a worksheet by its name, you first of all find out its resource ID from the sheet name in the workbook part, and then we can go open up the appropriate worksheet using the OpenXML SDK for JavaScript. It also helps me to have this XML up so that as I am typing in the code, it reminds me of what are the parents and children of all of these XML elements. I'll stop that debugging, and I'm going to dock my Visual Studio over here, and I'll dock Notepad++ over there so I can look at it. So now I need to get the sheet element with a given sheet name. So let's write a little expression to do that. I'll call var sheet element is equal to workbook xdoc, and I'll dot into the root, and that's the workbook element. I'll dot into element, and I am going to pass the name s.sheets. And this is there because I declared that s variable near the top of the example and assigned it to OpenXml.s. And once I've gotten that sheets element, then I need to dot into elements s.sheet. So this is going to then select these three elements in the XML tree. And so I need to have a where and have this where be based off of the name attribute. So let's come back over here and say dot where. And this is where it's slightly different using JavaScript. In order to write your Lambda expression in JavaScript, you have to do function. I'll call it sh. That's a good variable name for my function. And I'll close off everything there. Put a semicolon there just for a minute so that syntax parser is happy. And then I am going to be looking for sh.attribute. And it's this name attribute. It's in no namespace. You can use the no namespace variable that is defined in OpenXML, but I actually find it's more convenient just to type in the name of an attribute that has no namespace. And I'm going to dot in dot value, and this should return the actual value of that attribute. And I'm going to do a triple equals here and sheet 1, compare it against sheet 1. We could, of course, parameterize this and have this sheet 1 be defined in some variable up above or what have you. That's just a implementation detail. So this is going to return a sheet element where the name is sheet 1, but there's one minor problem here is we don't really want this to be where, we really want it to be first or default. So now at the end of this process, sheet element is either going to be null or it's going to have a sheet element in it. It's reasonable and possible that we have supplied a name of a sheet that doesn't exist in the workbook. So good programming dictates that I should say if sheet element here and use the falsy JavaScript idiom to make sure that I actually have found a sheet element. Then if I have that sheet element, I now can get the ID of that sheet element. So I'm going to do var ID is equal to sheet element dot attribute r dot ID dot value. And there are a few things here that if this were an invalid spreadsheet, this expression could fail. And also if this were an invalid workbook, you could also see that if there weren't a name attribute on this sheet, that would also fail. I am going with kind of a less defensive strategy here in JavaScript. I'm making the basic assumption that we have a valid spreadsheet here. Now let's make sure that we actually have the right ID here. So I'm going to do an alert ID and just make sure that we actually have that ID as appropriate. And I can get rid of that line that dumps out the workbook X document to a string. I'll save that and press F5. And what we should see is we should see an alert that has our ID 1 in the alert box. And in fact, that's exactly what we have. So we're in good shape so far. So two strategies that I've used here. One strategy is that I dumped out the X document of the workbook part and dumped it out to a string, and then I stopped and examined the string in the Visual Studio 2012 debugger. And another strategy that I did is I got the ID out, and because I knew it was a very short string, I just threw it up in an alert. So now that we have the appropriate ID, we can now get the part by ID from the workbook part. This will be the worksheet part. So var worksheet part is equal to workbook part dot get part by ID, and I'm going to pass in that ID. Now, once again, if we had an invalid workbook, it could be possible that this get part by ID would return null or something like that if we didn't actually pass in a valid ID. We're making the basic assumption that we have a valid worksheet in this scenario. So now that I've gotten the part by ID, let's make sure that we have the right part there. So I am again going to get the X document and dump it out to a string and take a look at that. So var worksheet X document is equal to worksheet part dot get X document. And then var Z is equal to worksheet X document dot to string true. And we can delete that. So now we should be able to run, and when we hit this breakpoint, we should look at Z, and we will have the worksheet part in a string. There's our Z variable, and sure enough, there's our worksheet part, and we can see our 1, 2, 3, 4, 5, 6 right there in the worksheet part. So I am going to Control A and copy all of that out. And again, I am going to come over to my Notepad++, create a new tab, and paste all of that in there so that I can use it as I'm further writing this code. I'll stop debugging over here. So now we need to create a new first cell, this upper left cell, the A1 cell, and we want to create it with a value of 1000. So the first thing to do is to get the upper left cell. So one thing I'm going to do here is I don't need to keep that Z variable around any longer. And theoretically, it is possible to have a worksheet that has no cells in it. So I am going to test if first cell is not falsy, if it has a value of some form or another in there. I'm writing very simple code here. Later on, as I mentioned, I have some designs to give you lots of good things to help you query and create workbooks and worksheets in a whole lot easier way, but all in good time. We have to walk before we can run. So right now we're still working with the ability just to go and get the parts and work with the contents in the parts. So now that I have that first cell, I need to create a new first cell. So I'm going to create var new first cell is equal to a new X element, and the X element name is going to be s.c, and it's going to have the same R attribute, in other words, its address. So I am just going to pull that in. I'm going to say first cell.attribute R. So that in my functional construction here, where I'm creating this new C element, calling first cell.attribute pulls in that attribute from the old first cell. And I also need a new V element that has the value of 1000. So I'm going to go and the value is going to be 1000. And I can close off the parentheses for that X element constructor. And our last job is super easy. We just have to take first cell dot replace with new first cell. And per the semantics of OpenXML for JavaScript, that's all we have to do. By going in and manipulating that XML tree that we got using the getXDocument call, we are modifying that part automatically. It'll get synced out to that part properly. It uses appropriate caching semantics so it doesn't do any extra work that it doesn't need to do. And so let's take off our breakpoint right here and let's just run this and see if everything works as planned. If it doesn't, we'll have to go in and debug it, but we'll see. Press F5 and it gives me the save button, and I'm going to do file and save as, and save it as saved spreadsheet, and I'm saving it to my desktop, and I'll open the folder, and when I open this I should have 1000 in the upper left cell, and there we have it. Well, that's the end of this screencast. Main point I wanted to cover was, first of all, was how to use PowerShell to create a literal document and put it right into your JavaScript application. Second of all is how to write the code and use Visual Studio to do a bit of debugging and to interactively develop your code by looking at the XML that you copy out of variables that you created in JavaScript. When you use these techniques, it becomes pretty easy to put together little JavaScript applications that access OpenXML documents and spreadsheets and presentations. See you next time.